think Colina has joined.
Yeah. Woo! Sage your boys on the track. Let's go. Pop it like a drop, a sweet explosion.
Step in the room, candy coated vibes. Sparkles in the air, we electrify. Drip like honey, golden on my tongue. We ain't slowing down, the party's just begun. Sip, sip, take a little taste. Heartbeats faster, no time to waste. Colors swirling, lights collide. We ride the sugar wave all night. Sugar rush, hey, popping like confetti, dancing crazy. Yeah, we're always ready. Turn it up, the beat won't stop. We're fizzy like soda. Pop, pop, pop. Sugar rush, taste the sweet reaction, melting hearts with every interaction. Feel the buzz, don't ever drop. We're sweet like candy. Pop, pop, pop.
Yo, check it. Said you're on a candy spree. Bubblegum dreams set the sugar free. Lollipop flavors, mix them all night. Cotton candy skies in the neon lights. Snap back, glow up, shine like a jewel. Boys too sweet, breaking every rule. Drip that caramel smooth and slick. With the sugar kings, better take your pick.
Sip, sip, take a little taste. Heartbeats faster, no time to waste. Colors swirling, lights collide. We ride the sugar wave all night. Sugar rush, popping like confetti, dancing crazy. Yeah, we're always ready. Turn it up, the beat won't stop. We're fizzy like soda. Pop, pop, pop. Sugar rush, taste the sweet reaction, melting hearts with every direction. Feel the buzz, don't ever drop. We're sweet like candy. Pop, pop, pop. Sprinkle starlight, dripping chocolate rain. Every heartbeat calling out your name. Spin the world, let the colors ignite. Sugar rush, taking over tonight. Sugar rush, keep it on replay. Party never ends. We can dance all day. Turn it up, the beat won't stop. We're fizzy like soda. Pop, pop, pop. Sugar rush, taste the sweet reaction. Every move's a sweet distraction. Feel the buzz, don't ever drop. We're sweet like candy. Pop, pop, pop.
Sage your boys, popping non-stop. Sugar rush forever. Pop, pop, pop. Man. Yeah. Woo! Sage your boys on the track. Let's go. Pop it like a drop, a sweet explosion.
Step in the room, candy coated vibes. Sparkles in the air, we electrify. Drip like honey, golden on my tongue. We ain't slowing down, the party's just begun. Sip, sip, take a little taste. Heartbeats faster, no time to waste. Colors swirling, lights collide. We ride the sugar wave all night. Sugar rush, hey, popping like confetti, dancing crazy. Yeah, we're always ready. Turn it up, the beat won't stop. We're fizzy like soda. Pop, pop, pop. Sugar rush, taste the sweet reaction, melting hearts with every interaction. Feel the buzz, don't ever drop. We're sweet like candy. Pop, pop, pop.
Yo, check it. Said you're on a candy spree. Bubblegum dreams set the sugar free. Lollipop flavors, mix them all night. Cotton candy skies in the neon lights. Snap back, glow up, shine like a jewel. Boys too sweet, breaking every rule. Drip that caramel smooth and slick. With the sugar kings, better take your pick.
Sip, sip, take a little taste. Heartbeats faster, no time to waste. Colors swirling, lights collide. We ride the sugar wave all night.
guys, good evening. Greetings to each and every one of us, wherever we are watching the stream from. All right. So, guys, good evening and welcome to Shaken Hour. This is episode 23. So, today we want to look at more questions, definitely, on mathematics. But then I am sharing a poll so that we can try and answer the poll. So the poll is, do we want to do some physics MCQs, right? That is up to us. So if a lot of people vote yes, then we'll do physics MCQs tomorrow. If no, then we'll continue with the mathematics. Are we okay? So, hi, Colina, how are you? Colina, please, how are you? Right, seems Colina, she's not with us. So let's start with some questions. She will be right back. Let's start with some questions for today. So yesterday we did a lot about logarithm, but we still have some questions under logarithm. So let's try to wrap things up with logarithm today. Okay, so I have a very beautiful question here. So I have here, so we have example number 1. For what value of x will, and we have the equation log base 2 4x plus log base 2 x plus 4 be equal to 7. Okay, so this is the question, and we have the possible options. A is 2, B is 4, C is 6, then D is 8. All right, guys, so let's have a look at this problem. Let's try our hands on this problem. So for what value of x will log base 2 4x plus log base 2 x plus 4 be equal to 7? So that is the question that we have. Then we have our possible options. We have A is 2, B is 4, C is 6, and then D is 8. So anyone with an answer for us? Colina, do you have any answer for me? For what value of x will log base 4x plus log base 2 x plus 4 be equal to 7? Okay, so whilst we wait for Colina to give us her answer, and for the others who are also watching to give us their answer, let's look at the solution to this problem. So we have the expression, let me start from here, log base 2 4x plus log base 2 x plus 4, and this is equal to 7. Now we can see that we have two logarithm expressions over here, and then they are adding each other. So when two logs are being added, it means that we are multiplying them. So we have log base 2 4x multiplied by x plus 4, and this is equal to 7. So from here, the base, which is the 2 over here, can go and raise to the 7th power, and that will get rid of the log over here. So we have 4x into bracket x plus 4 is equal to 2 raised to the power 7. Are we okay? So from here, we only need to expand our brackets and also solve for the value of x. All right, so from here, 4x, just a minute. So from here, we have 4x multiplied by x, that will give us 4x squared. Then we have 4x multiplied by 4, that will give us 16x. And this is equal to 2 raised to the power 7. 2 raised to the power 7 will give us 128, sorry. Yeah, so this is what we have. So from here, we have 4x squared plus 16x minus 128, and this is equal to 0. Are we okay? Now we can see that they are quite huge numbers, so we divide both sides, divide all terms by 4, or divide through by 4, divide through by 4, just to reduce the number. So we'll have x squared here plus 4x minus 32 here, and this will be equal to 0. So now that we have this expression, we can just go ahead and solve for the value of x, or factorize the expression that we have. So I will erase this part. Then we have 1 multiplied by 32, that will give me 32. Two numbers that if I add or subtract, I get positive 4, but if I multiply, I get negative 38. So 4 and 8 will give us that precisely, positive 8 and then negative 4. So we will have x squared plus 8x minus 4x minus 32 is equal to 0 over here. So from here, I can factor out x. I'll have x into bracket x plus 8 here. Then between negative 4x and negative 32, negative 4 is common, so we factor that out. We will have here x minus 8 here, sorry, plus 8, and this is equal to 0. So when we do the grouping, we will have x minus 4. Okay, Colina is saying b. Okay, so we have x minus 4, x plus 8 here, and this is equal to 0. So therefore, this implies that the value of our x is equal to 4, and x is equal to negative 8 when we equate them to 0. Okay, and so because x cannot be negative, therefore means that our value of x is 4, and that is correct. So the correct answer is 4 over here. That is option B. So Colina, you have that answer correct. Okay, so let's have a look at another question. So we have here, if log base 10 y plus 3 log base 10 x is greater or equal to log base 10 x, you are to express y in terms of x. Basically make y the subject. So we have option A over here, y is greater or equal to 1 over x. Option B here, y is less or equal to 1 over x. Option C, y is less or equal to 1 over x squared. Then option D, y is greater or equal to 1 over x squared. Okay, so this is the problem we have, and we are supposed to express y in terms of x. So please, let's try our hands on this question. Okay, so Vishal, thanks for joining. And Vishal is saying option D. Okay. Vishal is saying option D. Okay, so 2 people have also voted that we do the physics MCQ. Okay, so tomorrow we'll be doing physics MCQ. Physics MCQ. We've been doing maths for so long. Let's do physics MCQ tomorrow. All right, so Colina, what do you have for me for this? Vishal has D. Do you want us to do it together, or you are trying your hands on it? All right. So let's look at the solution to this problem. So for this particular problem, we have here, sure, log base 10 y plus 3 log base 10 x equal to log base 10 x. We have to make y the subject. So basically, the first thing we do over here, the 3 over here, we send it to become the power of x first. So we have log base 10 y plus log base 10 x will now be cubed, then this, then log base 10 x. So from here we can see that these two are adding, so we multiply them. So we have log base 10 y multiplied by x cubed. Okay, this will be greater or equal to log base 10 x. So if we take antilog of both sides, taking antilog of both sides, we will have s cube y, which is from here. Once we take the antilog, the logs will go. So we'll have s cube y, that is y multiplied by s cube, and that will be equal to just x over here. And you can remember we have to express y in terms of x. So we divide both sides by x cube. So this will cancel this. So our y is now equal to x over here, x cubed, we can write it as x multiplied by x squared. Are we okay? So the x here will cancel the x here. So therefore our y is equal to, here we'll have 1 at the top over x squared here at the bottom. Remember the sign here is greater or equal to, so it's greater or equal to. So this side as well is greater or equal to. So this is our answer, and so option D is the correct answer, just like Vishal has said in the live chat. So Vishal, you are correct, and Colina, this is how we got the answer. Please, I hope you understand. Colina, are we okay? I believe so. Okay, so I'll proceed with the next question. All right, so here we have oh guys, if you want us to do the physics MCQ right now, we can do it right now. So do you want us to do it right now? Just let me know. We can do it right now. So I have given that 3 log base 10 y plus log base 10 x. Then we have minus 2 is equal to 0. Express x in terms of y. Okay, so guys, we'll do the physics just after this question. So let's try our hands on this question and then we switch to the physics. So please, let's solve this problem and then we will move to physics. Okay, it's already here. So we have Munaf is saying B, Vishal is saying B, okay? Colina, what do you have? Okay, Colina is also having B. So let's look at the answer. Yes, so the correct answer is B. The correct answer is B, so we can proceed. So guys, we have a couple of, let me list the chapters so that you guys will vote on what we should do. So we have 1, work, energy, and power. We can do that. Then we can do Ohm's law or simple circuit. And then we can also do dimensional analysis. We can also do forces. Vector, simple harmonic motion. There's a lot over here. And then this is current electricity, right? So we can do current electricity as well. Current electricity. So guys, which one are you going for? Which one should we go in for? Because I want to start with work, energy, and power. Then we move to electricity, current electricity. That is what I was going in for. Okay, so Vishal is saying we should do work, energy, and power. Yes, I also agree. So let's quickly start with that. Okay, so I have here a question. An object of mass 0.5 kilograms is thrown vertically up with a velocity of 30.0 meters per second. So we have to calculate the potential energy, at the maximum height. Are we okay? Take gravity to be 10 meters per second squared. So we have option A, we have 150 joules. Option B, 225 joules. Option C, we have 450 joules. And then option D, we have 900 joules. Okay, so this is the first question we have for the physics. Okay, so Vishal is having 225 joules. Okay, anyone else? Okay, Munaf is having 225. Okay, very good. Colina, what do you have? So guys, let's give Colina 1 minute to do hers, and then we proceed to look at the answer. Okay, so Vishal is explaining how we solve it in the live chat. So let's proceed to look at the solution to the problem. So what I normally do is that I need to read the question, write down the parameters that I have before I continue. So I have here an object of mass. So my mass is 0.5 kilograms, and it has been thrown vertically upward with a velocity of, so that means our initial velocity is 30 meters per second. We have to calculate the potential energy at the maximum height. Are we okay? And then we've also been given gravity to be 10 meters per second. All right, so if I look at this, it means that first of all, I need to find my maximum height. And then we know that in physics, when you throw, or in kinematics, when you throw an object at the maximum height, final velocity is 0. Okay, because that is where it will stop before. Final velocity is 0 because it has initial velocity. So at maximum height, final velocity is 0. So using the formula, v squared is equal to u squared minus 2gh, where the h is the maximum height. We will have this to become, if I make, because v squared is 0, so I'll ignore it. So I'll make 2gh the subject. So 2gh is equal to u squared. So from here, it means my height will now be u squared over 2g. And that will be equal to the initial velocity squared, which is 30 squared over 2 times the gravity. Okay. And that will give me, here will be 900. And this will be 20. So I have 900 divided by 20, and that will give me the height to be 45. Are we okay? So now that I have my height to be 45, I can then go ahead and calculate the potential energy. So potential energy, we know, is mass times gravity times height. Are we okay? We already have our mass to be 0.5 multiplied by gravity, which is 10, multiplied by our height, which is 45. Are we okay? So this is 0.5 multiplied by 10. That will give us 5 multiplied by 45. And that is equal to 225 joules as our answer. Yes, so the correct answer here is option B, as rightly said by Vishal and Munaf. So Vishal is saying first we find the height by using V is equal to the root of 2gh. I agree. And then we get a potential energy by putting it in the formula mgh. I agree. Totally agree with you. And you guys are correct. Since Colina is not on the line, so you guys are correct. All right, so that is for the first question. Let's proceed with the next question. So I have here a body is pulled along a horizontal plane by a force of 15 newtons over a distance of 20 centimeters if the force makes an angle of 30 degrees with the horizontal surface, you have to calculate the energy used. So I have here option A is 2.6 joules, option B is 4.5 joules, option C is 9.0 joules, then option D is 12.5 joules. Okay, so let's try our hands on this question. So anyone, yeah, I know this is going to take some time. So you guys have 2 minutes. 2 minutes. Let's solve it. Okay, Vishal has 2.6 joules. Okay. Munaf, what do you have for me? Colina, I hope we've not left you behind. Colina, I hope we've not left you behind. And you are still with us. Munaf, are you there? Okay, so we have 1 more minute. After that, we will solve it together. Almost there, almost there. Okay, so guys, let's look at the solution to this problem. So we have here a body is pulled along a horizontal plane by a force of 15 Newton over a distance of 20 centimeters. If the force makes an angle of 30 degrees with the horizontal, so it means that when we have this is our horizontal plane, the force made an angle of 30 degrees, so the angle here is 30 degrees, and then the object being moved, let's say this is the object, are we okay? And then it is being moved by a force of 15 newtons, and then the horizontal distance here is 20 centimeters. Are you okay? So when we complete this triangle like this, we have to find the energy used. Are we okay? Okay, now first of all, the energy used is the same as the work done, so basically we have to calculate the work. Now we know that work is force multiplied by distance. Now the distance in this case is at an inclined level, or there's an angle associated with it, so the distance will not just be 20, it will be 20 something, either sine something, cos something, or tan something. Now when we look at this, we have the hypotenuse, which is the h over here, so I'll use a different color over here. We have the hypotenuse, which is this guy. We have the hypotenuse, we have the opposite, and then we have the adjacent over here at the bottom. So when we look at the parameters that we have the hypotenuse, we have the adjacent. Are we okay? Which means that the angle, we have something we call so ka tua. Okay, so the SOH, it means you use sine when you have opposite and hypotenuse. The car is you use cos when you have adjacent and then hypotenuse, and you use tan when you have opposite and adjacent. In this case, we do not have our opposite. We don't know any angle over there. So what we did have is adjacent and then hypotenuse. So which means that the distance will be multiplied by cos theta, or cos the angle. So our work over here, or energy, will be equal to the force, which in this case is 15, multiplied by the distance. Now remember, the standard unit for distance, okay, is in meters, not centimeters. So we need to convert the centimeters into meters. That is what we need to do. We need to convert the centimeters into meters. Now from centimeter you go to decimeter, then you go to meter. Are you okay? So it means 100 centimeters equals 1 meter. So 20 centimeters will be, into meters will be 20 divided by 100, and that will give us 0.2. So this is 15 multiplied by 0.2, cos the angle here is 30. Are we okay? And so if we put this into our calculator, 15 multiplied by 0.2 cos 30, this will give us 2.6 joules as our answer. So yes, this is the answer for our problem. So Vishal is saying that first we find the horizontal component of force, then find the work done by using force multiplied by distance, exactly as Vishal has said. So the horizontal component of this is the cos over there, so it can be F cos theta. Remember, they are all multiplying, so if you find the horizontal component of the force, it will be F cos theta, then multiplied by the distance, which in this case can be S or D, no matter how you want to express it. Are you okay? So as Vishal is saying, the horizontal component of the force will now be 15 cos 30. And so once you get the answer over here, you multiply it by 0.2, and this will still give you the 2.6 joules as our answer. Are you okay? So yes, Vishal, you are right, and yeah, you got the answer right. Option A. All right, so let's. Hi, Hichi, hi, welcome. Today we are doing physics. I'm glad you decided to join. Today we are doing physics. Okay. So just a quick one before we go on. What is the SI unit of power? What is the SI unit of power? Just a question for us to answer. Just leave it in the live chat. What is the SI unit for power? Okay, so I have the next question for us. I have here a boy of mass. Okay, yes, so the SI unit of power is what? Okay, so we have a boy of mass 70 kilogram, climbed. Yeah, I said power. So a boy of mass 70 kilogram climbed a hill 1,000 meters high. Wow. We are to calculate the maximum, energy gained by the boy. So you have to take gravity to be 10 meters per second squared. And then our possible options are, we have A 3.5 times 10 raised to the power 4 joules. Option B, I have 7.0 times 10 raised to the power 4 joules. Option C, I have 3.5 times 10 raised to the power 5 joules. And then option D, I have 7.0 times 10 raised to the power 5 joules. So we are doing work, energy, and power, yes. And so this is the next question that we have. Wow. Vishal is saying option B. So, Ichi, what do you have for me? Okay, Vishal is saying, sorry, option D. Okay. We move to option D. Okay. Ichi is saying B. Okay. Okay. Let's look at the solution together. So I have here a boy of mass 70 kilograms. So my mass is 70 kilograms. And he climbed a hill 1,000 meters high. So my height is 1,000 meters. That is also in the right unit. Okay, so Hichi is saying is D. Okay, very good. So the gravity has been given to me to be 10 meters per second squared. I'm to calculate the maximum energy gained by the boy. Okay, now the maximum energy here is the potential energy that he gained at that particular height. So the potential energy here is mass multiplied by gravity multiplied by the height, and that will give us the mass is 70 multiplied by the gravity, which is 10, multiplied by 1,000, which is for the height. So this will give us 7.0 times 10 raised to the power 5 joules. Sorry, let's see, 1 2 3 4 5. Yes, so option D, yes, option D becomes our correct answer in this case. So you guys are right. Are we okay? You guys are right. Very good. Now let's proceed to the next question. Wow, I have a very complicated one over here, but you guys can solve it. So I have a 10 kg mass falls from rest from a point 30 meters above the ground. We are to calculate its total energy on reaching a point 10 meters above the ground, given that gravity is 10 meters per second squared. So I have my option A is 1 kilojoules, option B is 2 kilojoules, option C is 3 kilojoules, then option D is 4 kilojoules. Okay, Shukla is saying option B. Okay. Shukla is saying option B. Okay. Who else? Vishal is also saying 2 kilojoules, which is option B. Okay. Ichi, do you have any answer for us? Guys, the question is saying we have to calculate its total energy. Are you okay? So the total energy here will be the sum of the kinetic energy and the potential energy. Are we okay? They say a body, a 10 kilogram mass fall from rest from a point 30 meters above the ground. Calculate its total energy on reaching a point 10 meters above the ground. So we are calculating the energy at 10 meters above the ground. Are we okay? So at the height of 10 meters, okay, at 10 meters above the ground, it means it has traveled a distance of 20 meters. So we need to take that into consideration when we are solving. All right, so let's look at the solution to the problem. So I have a mass of 10 kilogram, and then it says it falls from rest. Okay, so at this point it is at rest from a point 30 meters above the ground. So it was at rest at 30 meters above the ground. We have to calculate the total energy. Like I said, total energy in this case is the potential energy plus the kinetic energy on reaching the point 10 meters above the ground. So after reaching 10 meters above the ground, so let me make this D 2, and then the first distance, initial distance D1 or DI will be 30 meters. Gravity is 10 meters per second squared. Yeah, so Vishal is now saying 4K. Okay, so let's look at that. So at the point where we are supposed to calculate for the total energy, it means that the mass has fallen from a height of 30 to a point of 10 meters. Okay, so it means that the distance traveled or the height traveled will be 30 minus 10, which is 20 meters. Okay, remember at this point it has initial velocity of 0. Initial velocity will be 0 because it moved from rest. Are we okay? So when we use the formula, v squared is equal to u squared minus 2gh, and because this one it is coming down, this becomes plus. So the initial velocity here is 0. So our final velocity here, v squared, will be equal to 2 multiplied by gravity, which is 10, multiplied by the height, which is 20. And so this will give us 40. 40 multiplied by 2, that will give us 400. Are we okay? So v squared is equal to 400 over here. Are you okay? So from here we can find the value of v, but I'll leave v squared like this because our total energy is equal to the potential energy is mgh multiplied by the kinetic energy is half mv squared. We already have v squared over here. We know the mass already to be 10, and then we know the height over here to be 10. Okay, at the height of 10. Okay, so from here let's look at it. So our mass here we have our mass here is 10 multiplied by gravity, which is also 10, multiplied by the height. The height it has traveled is the 20 here, so we have 20. Are we okay? This is supposed to be plus. It's sum, not multiply. Yes, this is supposed to be plus. Sorry, thank you so much. I just realized that. So this is supposed to be plus. So yes, this all plus. I now have half multiplied by the mass, which is 10, multiplied by the velocity square is 400 already, so we'll leave it like that. No need to square it again. So here we have all this. It used to give me 2 and then 3 zeros. 1, 2, 3. Okay, plus this is half by this, that is 5. 5 multiplied by this is also another 2000, and this will give me a total of 4000 or 4 kilojoules. Yes, so the correct answer here is option D. Okay, yes, please. Yes, it's addition over here. Total energy is mgh, which is the potential energy, plus half mv squared. Okay, so yes, this is our answer, and our final answer is 4 kilojoules. All right, very good. Now let's proceed with the next question that we have. Okay, so we are going to look at a very interesting question. So we have a machine of efficiency, a machine of efficiency 80%, does 3000 joules of work. So we are to calculate the energy used in overcoming friction. This is what the question is saying. So we have option A, 600 joules, option B, 750 joules, option C 2400 joules, and then option D 3750 joules. Okay, so this is the next question, guys. Let's give it a try. So Vishal is saying 600 joules. Okay. Shukla, what do you have for me? Shukla, what do you have for me? Okay, seems like we've lost Shukla. So for the meantime, we are going to do the calculation ourselves. So, all right. So let's look at the solution to this problem. So we have a machine of efficiency 80%. So the efficiency of the machine is 80%. E is equal to 80%. And it does a 300,000 joules of work. Okay. So it means work output, which I'll represent with WO, output is 3,000 joules. Are we okay? So we have to calculate the work, the energy used in overcoming friction. Now, the formula we use over here is that work input, that is the amount of energy that you use or you input into a machine, is equal to the work output, which is the result that you've obtained, plus the energy used against friction. Okay, so or work done against friction. So let me use work done in that case. Work against friction. So the work against friction can be in the form of heat and so many things. That is why the efficiency of a machine is never 100%. Are we okay? So from here, we have the work output. We don't have the work input, but we have the efficiency. And we have to find the work against friction. So we will use the efficiency formula to find the work input, and then we do our subtraction to get the work done against friction. So here we know that the efficiency of a machine is equal to work output, are we okay, over work input over work input multiplied by 100%. So here we have 80 is equal to work output is 3,000 divided by work input. I'll use WI over here, and this is multiplied by 100. So here I'll have 80 WI is equal to 3,000. Then we add 2 zeros to it. So I divide both sides by 80. So my work input will be equal to this is 300,000 divided by 80, and this will give me 3,750 joules. Are we okay? So now that I have this, work done against friction, if I make work done against friction the subject, so work done, work against friction. If I make it the subject, it will be what? Work input or input minus output. Okay, so I send the output to the other side. So it will become input is 3,750 joules. Yeah, so Vishal is saying 750. Yes, it's supposed to be 750. So we have here this minus work output, which is 3,000, and this will give me 750 joules as my answer. So yes, Vishal, the answer is 750 joules, and yes, that is that. Okay. So apparently we've lost a lot of people along the way, but let's look at hmm, let's look at another question. Okay, so Vishal is saying he has not remembered the formula for efficiency. Yes, I think that was where you got it wrong. So we need to use the formula for efficiency over there. So here I have here an athlete of weight 600 newtons runs up a flight of stairs, a flight of stairs 10 meters high in 12 seconds. Calculate the power of the athlete. So I have option A, 75 watts, option B, 500 watts, option C, 720 watts, and then option D, 5,000 watts. Okay, so that is the next question we have. Okay, so Vishal is saying 500 watts. Okay, yes, that is actually correct. So let's look at it. Then we look at one last question and then we end the stream for today. So here we have the weight of the athlete. It's 600 newtons. We have the height here to be 10 meters. We have the time is 12 seconds. We have to calculate the power of the athlete. Are we okay? Now the power equals work done over the time taken. Are we okay? Now in this case, the work done, okay, will be the force or the weight multiplied by the distance over the time taken, and that will be equal to the weight is 600 multiplied by 10, which is the distance, all over 12 seconds. And now this will cancel itself 1, it will cancel here 2, that will cancel here 5. So this is done. So we have 5 multiplied by 100, that will give us 500 watts as our answer. So yes, the correct answer is 500 watts. So you are right. Okay, now let's look at one final example for today, and then we end today's live stream. So I'm looking for a very convincing last question. Okay, so let me give you a very simple one. There's no need to make it complicated. So we have here an object of mass 0.5 kilogram, has kinetic energy of 25 joules. So we have to calculate its speed. Okay, so I have here option A, 50 meters per second, option B, 25 meters per second, option C is 20 meters per second, then option D is 10 meters per second. Okay, now this is fairly easy. Okay, so Vishal is saying 10. Let's look at that. Okay, so let's look at this. Solution. So we have the mass of the object is 0.5 kilogram. That is the right unit. We've been told that the kinetic energy is 25 joules. And we have to find the speed. In this case, the velocity. That is what we do not know. But we know that kinetic energy, the formula is half multiplied by mass multiplied by velocity squared. So if I want to make velocity the subject over here, I'll multiply through by 2. So 2 multiplied by the kinetic energy is equal to mv squared. So I divide both sides by the mass. My velocity squared will be equal to twice the kinetic energy divided by mass. So if I take root of both sides, my velocity will not be equal to the root of 2 times the kinetic energy divided by mass. And that means my velocity is 2 multiplied by the kinetic energy, which is 25, divided by the mass, which is 0.5. So this is equal to the root of 2 multiplied by this will give me 50. 50 divided by 0.5, that will give me 100. So I have the root of 100, which is equal to 10 meters per second. So yes, the correct answer here is option D, and that is 10 meters per second. Okay, all right. So Vishal, thank you so much for staying with me until the end of today's stream. It's been a little bit over 1 hour. I wish to continue, but I got back from work. I have not eaten anything. My stomach is shouting on me, alerting me that I have to go and eat, right? And I don't have any snack around to eat. So yes, I will be ending the stream here tonight. But tomorrow we'll still continue with the physics. So we'll look at more questions on work, energy, and power. Then we move to current electricity, right? Ohm's law, how to calculate resistance, how to calculate a capacitance, uh, current, voltage, and all those stuff. Simple circuit problems. We'll be looking at that tomorrow during the live stream. So tomorrow we'll continue with phases, and those are the things that you are supposed to be expecting. Vishal is asking, sir, are you preparing for any exam? No, I'm not preparing for any exam. I'm only doing my project work, long essay writing, which is mind blowing. But yes, no, I'm not preparing for any exam as at the moment. Why do you ask? Vishal, why are you asking? Did I look like I was preparing for an exam or something? Vishal, why did you ask? All right, so yes, great. So please do revise notes on current electricity so that tomorrow we'll look at them. Just a quick one before we go. Let me tell you some of the things that you are supposed to prepare for. So 540, page 540. Okay. So so yes, we'll be looking at current electricity, like I said. So revise series connection, parallel connection of resistors, series connection, parallel connection of resistors, Ohm's law, Kirchhoff's law. Okay, I'll try to select the simple one so that we can solve. But yes, Ohm's law, Kirchhoff's law, internal energy of a battery. Okay, and then yeah, you should be good to go. So resistance in parallel, resistors in parallel, resistors in series, and then some circuit diagrams. Yes, those are the things that we'll be looking at tomorrow. Oh yes, so Vishal is saying because I'm preparing for a G exam, so when you are giving questions in stream, these are like questions of preparing for a competitive exam. No, so Vishal, the thing is that these are past questions from West Africa. Okay, so these are some of the questions that we in West Africa we have to go and write the exam on before we can go to the university. Okay, so it's a past question for senior high school student or high school student, and then from there you can move to the university. So these are not simple questions, right? They are like entrance exam questions to the university. Are you okay? So I'm sure it will be helpful for you for your GE exam. Okay, so yes, it will be very, very helpful. Trust me, I'm filtering the questions and I'm taking the simple ones that we can quickly solve on the stream and proceed. Because if we want to look at those that are a little bit complicated and it will take some time, I'll have to do a lot of explanation that if you don't understand the concept, it will look like I'm just talking in vain. So yes, I'm filtering it and I'm selecting the simple ones. But yes, these are past questions. They are not just random questions. They are past questions. Are you okay? Yes, they are good questions for entrance exam. Very good questions for entrance exam. Very good questions. So yes, that is what they are. It is what they are. So this is for the physics. This is the past question, I think, from 1993 to 2021. This is for further mathematics. Okay. Also 1993 to 2021, the same. This is our general mathematics. Are you okay? And then I have the chemistry as well. I have the biology, the general science. They are all there. Mine is JEE exam, also word second hard exam. Oh, okay. Oh, okay. I have prepared good through your stream. I'm glad my stream is helping you prepare enough for your JEE exam. So what I'll do is that I'll write the name of your exams, JEE. So immediately before I sleep today, I'll go and read a little bit about your JEE exam, okay? And then I'll have a look at some of their past questions, and let's try and see if we can solve some of them. So Vishal, I'm sure you are in the WhatsApp platform. So if you have any past question on the JEE exam, just send it to me on the WhatsApp platform or to me via email at mysciencetutorials@gmail.com so that we can solve them in the subsequent streams. Are you okay? But yes, that is really helpful. All right. So all the best in advance. And yes, also very soon I'll be streaming. Will be doing a normal stream over here, but I'll also be streaming for those who are members of the channel. So right now I have some few people who are members of the channel. They've joined the membership program, and then for them they are doing CAT, common admission test. They are doing CAT. So I think those people are for MPhil. They are going for their masters in MBA. They are doing their MBA, so they need to write their common admission test. So CAT. So yes, I'll be streaming for those people exclusively. So Vishal, you are going for JEE, but if you want exclusive content one-on-one where I'll focus on just questions that are JEE related, you can just for as little as 0.99 cents, you can join the membership. I think the join button should be somewhere around on your screen. That is if you want to join. Else, we can do it on WhatsApp or we can do it on the regular stream over here. So yes, thank you so much. Yes, thank you so much, Vishal. Thank you for staying with me up until this time. And yeah, bye-bye. We'll talk behind the scenes. We'll talk on WhatsApp. So enjoy some few music and then yeah. Hey, is he Vissel? Vissel, hello. You joined a little late. We are done with all the calculations and all the things. But yes, tomorrow at the same time, 7 p.m. GMT, we'll be doing the stream again. This stream is for students. So we solve past questions. Are you okay? We solve past questions, mathematics, chemistry, physics, biology. We solve past questions. And if you have any specific exam that you are preparing for and you need my assistance on that, just send me an email. My email is the same as the name of the channel, mysciencetutorials@gmail.com. Okay, the name of the channel together, mysciencetutorials@gmail.com. That is my email. You can send me the questions via email and then I will respond to you and then we'll solve it in the subsequent streams. Are you okay? So Vissel, I'll be looking forward to seeing you tomorrow, same time, 7 p.m. GMT. Don't forget to mark your calendar. Okay. All right, guys. So in the absence of any other question, any other contribution, Then I will bring the stream to an end over here. Then Vishal and I will continue behind the screens. All right, bye guys.
Yeah. Woo! Sage your boys on the track. Let's go. Pop it like a drop, a sweet explosion.
Up in the room, candy coated vibes. Sparkles in the air, we electrify. Drip like honey, golden on my tongue. We ain't slowing down, the party's just begun. Sip, sip, take a little taste. Heartbeats faster, no time to waste. Colors swirling, lights collide. We ride the sugar wave all night. Sugar rush, hey, popping like confetti, dancing crazy. Yeah, we're always ready. Turn it up, the beat won't stop. We're busy like soda. Pop, pop, pop. Sugar rush, taste the sweet reaction, melting hearts with every interaction. Feel the buzz, don't ever drop. We're sweet like candy. Pop, pop, pop.
Yo, check it. Said you're on a candy spree. Bubblegum dreams set the sugar free. Lollipop flavors, mix them all night. Cotton candy skies in the neon lights. Snap back, glow up, shine like a jewel. Boys too sweet, breaking every rule. Drip that caramel smooth and slick. With the sugar kings, better take your pick.
Sip,